So don't worry. So to optimize means to determine the values of the independent variables so that the values of a function that model quantities such as cost, area, number of objects, or distance can be minimized or maximized. So these are the rules to follow. Just like curve sketching, there is a rules to follow when it comes to finding the maximum or minimums of a natural log. So if a function f of x has a derivative at each point on the closed interval where x is between b and a, calculate f of x at all points on the interval x is greater than or equal to a, less than or equal to b, where f prime of x is equal to 0, and at the endpoints a and b. Okay. So not only are you going to find where your slope of the tangent is 0, but you also have to find the values of your function at the lowest point in that interval and at the highest point of that interval as well. The absolute max value of f of x on the closed interval, where x is between b and a, or ab, is the largest of these values, and the absolute minimum value of f of x is on the interval, is the smallest in these values. So, similar to graphing, find the critical numbers, x value by determining f prime of x is equal to 0, and wherever f prime of x does not exist. So if my denominator is 0, it is not, you cannot evaluate it at that point, which means there's going to be an asymptote of some sort. Find the domain of the function to be optimized. Check your critical numbers to see if they belong in the domain. Substitute the critical numbers and endpoints into f of x, and then compare y values for the highest and lowest values. So let's start with a simple example. So we want to determine the absolute max and minimum for each of the following functions. So remember, my derivative of anything that has e to the x is just e to the x and then the derivative of your exponent. So for example, this one, my derivative would be 3 times e to the x times the derivative of my exponent x, which is just 1, plus e to the power of 2x times the derivative of my exponent, which is 2x, which just gives me 2. And if I simplify, I get 3 times e to the power of x plus 2 times e to the power of 2x. So now what I need to do is I need to set my derivative equal to 0. So I get 0 is equal to 3e to the x plus 2 times e to the 2x. Is there a common factor that I can factor out between 3e to the power of x and 2e to the power of 2x? And if so, what is that factor? E to the x. Thank you, Priyanshu. I can factor out e to the x. Again, this goes back to grade 10. We're just going to factor. Which means that I have e to the x equal to 0, and I have 3 plus 2 times e to the x is equal to 0. So if I take the ln of both sides of e to the x, I get ln e to the x is equal to 0, or is equal to ln of 0. Will this ever happen? Will e to the x ever equal 0? No. So you would say this is invalid. So that is invalid. Now, I get 3 is equal to negative 2e to the x, divided by negative 2. And I get negative 3 over 2 is equal to e to the x. Will this ever happen? If we look at my natural log function graph, will I ever get a negative value? No. Which means this is also invalid. So now my restriction is between 0 and ln 2. So I need to check what my f at 0 gives me and what f at ln 2 gives me, and if I'm going to get a max and a min. So if I sub in f at 0, I get 3 times e to the 0 plus e times 2 to the 0, which means I get 3e to the 0 plus e to the 0. And e to the power of 0 gives me what value? 1. Which means I get 3 times 1 plus 1, which gives me 3 plus 1, which gives me 4, which means f at 0 gives me 4. Now, I don't know if this is a max or a min yet, because I need to evaluate for f at ln 2. So for f at ln 2, I get 3 times e to the power of ln of 2 plus e times 2 to the power of 2 times ln 2. So I get 3e ln to the 2 plus e to the power of 2 ln 2. Now, with my exponent laws, okay, I know that, or my log laws, I know that this is just stays the same. And then I get e times ln 2 to the power of 2, which is e to the power of ln 4. And according to my rules of laws, of my laws of logs, I know that e to the power of ln over 2 just gives me x back, which will be 2 and 4. So I get 3 times 2 plus 4, which gives me 10. So f at ln 2 gives me 10, which means I have a max at ln 2 and 10, and I have a min at 0 and 4. That's fine. I'm just going to mark you late on attendance in 2 seconds. So now let's try our next example, which is f of x is equal to e to the negative x times x plus 2 to the power of 3. So we have our p of x and our q of x. So what derivative law are we going to have to use to help us find the derivative of this function? Product rule. Okay. So my p of x is e to the negative x. So I need to find p prime of x, which is just e to the negative x times the derivative of my exponent, which is negative 1. So I get negative e to the negative x. That would be my p prime of x. And now I need to determine my derivative of q of x, which is x plus 2 to the power of 3. Who can tell me what the derivative of x plus 2 to the power of 3 gives me? Yep, 3 times x plus 2 squared. So now I can figure out my derivative using my product rule. So I can write f prime of x is equal to negative e to the negative x times q of x plus e to the negative x times 3x plus 2 all squared, which I can rewrite as negative e to the negative x times x plus 2 to the power of 3 plus 3 times e to the negative x times x plus 2 squared. So is there anything that I can factor out? What can I factor out from that expression? So I can factor out an e to the negative x, negative e to the negative x, and factor out an e to the negative x, and x plus 2 squared. That's what I can factor out. So just try to keep your e to the x as a positive. So that way is easier to work with. And what's left on the inside is also easier to work with. So what I'm left with is negative 1 times x plus 2 plus 3. So I get e to the negative x times x plus 2 squared minus x minus 2 plus 3, which means I'm left with e to the negative x times x plus 2 squared times 1 minus x. So now I have 3 factors. So I have e to the negative x is equal to 0. Can that ever happen? No. So this is invalid. So now I get x is equal to negative 2. What is my restriction on my domain? Would this be able, would this count as part of my solution? Remember, my restriction is x is between positive 2 and 0. No. So this is not in domain. And then I'm left with x is equal to 1, which is good because that is the only one that fits in my domain. So now I have three things to evaluate. I have to evaluate f at 1, I have to evaluate f at 0, and I have to evaluate f at 2. So let's evaluate f at 0. I get e to the negative 0 times 0 plus 2 to the power of 3, which gives me 1 times 2 to the power of 3, which gives me 8. Now, I don't know if that's a max or a min yet. Now, I need to evaluate f at 0. Sorry, f at 1. What am I doing? This should be f at 0 right here. Set up. Sorry. Now we'll evaluate f at 1. That was my mistake. So if I evaluate f at 1, I get e to the negative 1 times 1 plus 2 cubed, which means I get e to the negative 1 times 3 to the power of 3, which means I get 27 over e. And if you look back at lesson 1, what is the approximate value of e? What does it give us? 2 point what? Around 2.7. So if I take 27 and divide it by e, I get approximately 9.9. Now, can you guys evaluate f at 2 for me and tell me what you get? So when you plug in 2 for x, tell me what you get as your output. So when you're done, type in the answer in the chat. So you're evaluating f at 2. Thank you, Brianna. You get approximately 8.7. So where is my max and where is my minimum based off the values that we got within our domain? What is my max and what is my min? So my min happens at 0 and 8. And my max happens at 1 and 9.9. So hopefully this isn't too hard right now. Obviously we will try to get, we have 2 more examples to get through. so let's move on to the next one. Trying to see if anyone else joined before. I got Joel's here, that's fine. Mackenzie's not here, and who else isn't here? Manroop's not here. So Mackenzie and Manroop are not here. That's fine. All right, let's move on to the next one. So the concentration of two medicines in the bloodstream T hours after injection are C1. So the first injection, this is the first medicine, is T times e to the negative T. And at T, the second medicine in terms of T is T squared times e to the negative T. Which medicine has a larger concentration? Assume the concentrations are monitored for 6 hours. So which means that my domain is automatically 0, is greater than, less than or equal to T, which is less than or equal to 6. So let's try to see what happens when we try to take the derivative of the first medicine, which is C1 in terms of T, is equal to T times e to the power of negative T. So I have two different functions. So what derivative law do I need to use here? You have two functions. So what law are we going to be using? Product. We're going to be using the product rule. My P of x is T. My Q of x is e to the negative T. So my derivative of P of x, which is just T, is going to give me 1. And the derivative of Q of x is going to give me negative e to the negative T. Perfect. So we get the derivative of the first medicine is equal to 1 times e to the negative T plus negative e to the negative T times T. Which means that I'm left with e to the negative T plus T times negative e to the negative T. So now I can factor out an e to the T. So 0 is equal to e to the negative T times 1 minus T. So I have two roots. I have e to the negative T is equal to 0. Is this ever true? Is e to the negative T equal to 0? Is that ever true? No. Again, invalid. Then I have T is equal to 1. Does that fall within my domain? Yeah. So I can take T is equal to 1. So now I need to evaluate C1 at 0. I need to evaluate C1 at 1. And I need to evaluate C1 at 6. So if I plug in 0 for T, I get 0 times e to the negative 0, which just gives me 0. If I plug in e to the 1, I get 1 times e to the negative 1, which just becomes 1 over e. So what is 1 over e? What does it approximately give me? That's fine, Rami. So can someone tell me what e approximately gives me? It's about 0.37. Okay. And who can tell me what C when I sub in T for 6, what does C1 give me? Well, Priyanshu, you were kind of right. I said approximately 0.37. So if I round it up, 0.3678 is 0.37. So that's fine. Can someone tell me what happens with C1 when I sub in 6 for T? All right. It is approximately 0.015. So I'm looking for the highest or maximum concentration. What is my max for my first medicine? Where does my max happen at? At what T value? Yeah. So my max happens at 1 and approximately 0.37. So now what I want you to do is I want you guys to try and figure out what is my maximum value at my medicine 2, which is the function t squared times e to the negative t. Remember, I have two functions, so I need to use my product law. I'll help you out. P prime of x is 2t, and q prime of x is negative e to the negative t. So I want you guys to figure out where my max is going to happen, take the derivative of C2, factor it, and try to tell me where my max happens. So take around 5 minutes, and then if you are ready to type your answer, feel free to type in your answer. So again, I'll give you guys till 6:45 to try and figure this one out. Okay, so does everybody agree with Priyanshu? The max is at 2 and 0.54. Okay, so I got one agreement from Ashley. How about the rest of y'all? All right. So I can safely say that my maximum happens at t is equal to 2. Hello, Mac. Okay, so C2 of t has a max at t is equal to 2, which gives a value of 0.54. So which medicine has the larger maximum concentration? Remember, I need a therefore statement. So what would my therefore statement be? Therefore, medicine 2 has the larger maximum. So you guys are pretty good at that one, which is fine. I'm proud of all of you. Next one, I have a new product that has just come into the market and is a big hit. The success, however, does not last too long. Within a year, sales they have dropped drastically, given the number of sales per day measured in tens of thousands of the product is represented by the function nt is equal to negative 50 times e to the negative 4t minus e to the power of negative 3t after t years. What is the day that the most products are sold? Consider January 1st to be day 1, and how many products were sold on that day. Obviously, company that you probably should not have invested in after that terrible result where its sales have dropped drastically. So just a little pointer there. So I have my function, which is negative 50 times e to the negative 4t minus e to the negative 3t. So to take my derivative, again, this is pretty easy. I can take the derivative of each of these separately. So I get n prime of t is equal to negative 50 times negative 4 times e to the negative 4t plus 3 times e to the negative 3t. Let's factor my negative 50 in so that it's easier for us to find another common factor. So I got 200 times e to the negative 4t minus 150 times e to the negative 3t. So now my greatest common factor is going to be 50e to the negative 4t. Which means that I'm left with 4 minus 3 to the power of 3e to the power of positive t. So now I have two functions that I can have roots for. So the 50 doesn't really matter. So I got e to the negative 4t is equal to 0. Again, that can never happen. And I get 4 is equal to 3e to the power of t. Divide both sides by 3. So I get 4 over 3 is equal to e to the power of t. And to get my t value, I just have to take the ln of both sides. So I get t is equal to ln of 4 over 3. So now I can, ln of 4 over 3 is roughly around 0.29 years. Okay. So you can evaluate ln of 4 over 3 by just using your calculator and the button. So now I have to basically figure out how many products were sold in 0.29 years. So I know at n at 0, I had 0 products sold. And at 1, I had 1.57. Remember that I need to multiply this by 10,000 because my sales is measured in tens of thousands. And then finally, I need to evaluate my function at n of ln of 4 over 3, which gives me roughly 5.27. So I need to multiply that by 10,000, which gives me around 52,734 products sold on that day. So now in order for me to figure out at what day that happened at, my ln of 4 over 3 gives me 0.29 years. And remember, I have to figure out what day it was sold at. So how many days are in 1 year? I'm pretty sure that 7 was an accident. Yeah, that's fine. So in order to figure out how many days this was, t is approximately 0.29 times 365, which gives me an approximate 105 days. So if January 1st is day 1, at what month and day did they sell 52,000 products at? Let's see if you guys can figure it out. You have to figure out how many days are in January, how many days are in February, how many days are in March, and then how many days give you 105. We're going to assume that there's no leap year, so February has 28 days. So let's see who can figure out what the 105th day of the year is. And if it's your birthday, congratulations. Does anyone have their birthday on April 15th? On April 15th? No April 15th babies? All right, so that does it for this lesson. Okay, hopefully this wasn't